how we can apply it, okay, and mathematically especially we'll see it, then we go for actually the problem solving. So at the very beginning, and one of the type that will be actually our discussion, and on that type it has a classification, or maybe the subtype we can say in that, and those function we are going to discuss in detail, okay. So what is actually transformation, as in generally to define, Pratasha?
So transformation means movement of the object.
Movement of the objects, right? We are concerned in an image that the objects, they have a movement, especially the changes on the objects as well. Movement is related with the changes, isn't it?
Yes, sir.
If it does not change the coordinate spaces, then
It
actually
is
we cannot
geometry.
define them. Yeah, we cannot actually have a we cannot feel the movement actually if we don't have the spaces. So two type of this movement or transformation can be, right, Ashik? Can you tell me about the geometric and coordinate transformation, the basic difference between them?
First is about.
Ashik, can you hear me?
Yes, sir, I can.
Yes, the geometric transformation or and coordinate transformation.
Sorry, sir, I can't explain exactly.
So may I?
Yes, Pratasha.
So in geometric transformation, the object is really moving.
Okay.
Its position is changing, and
Hmm.
the static is the background. And
Right.
in coordinate transformation, here the object is static, but the background is changing its coordinate position.
Okay, that's good, Pratasha. Fairuz, Tanjim, Achal. Achal, can you tell me, give me some example? What could be a geometric transformation, or what could be the coordinate transformation? Can you hear me, Achal? Yes. Yes.
Um, no, sir.
I cannot hear you, Achal. Can you be a little bit loud and clear, please?
Oh, sorry.
Yes.
For
You're not.
example,
Yes.
I can say,
All right. Sharnika is here.
Yes, sir.
Yes, Sharnika, can you give an example?
Sir, in the geometric, sir, that time automobile is automobile moving while in backdrop it is a geometric transformation. But when we can keep fixed moving, so this is a coordinate transformation.
Like, yeah, just example, give me. Like first one you said about an automobile, a car. Okay, it is moving when your background is actually fixed,
Yes,
right?
sir.
But whenever you will see that your background is changing.
In the coordinate transformation, that time the background will be changing, sir.
But in geometric transformation, you will not find that the background is changing. Yes. Both of the cases, everything will be changed,
Yes, sir.
right?
Yes,
Now,
sir.
how we can actually generate the changes, that is actually the case. In geometric transformation, we will generate the change by moving the object, while the coordinate transformation, we will find the change by moving the background, okay, not the object. Then it is end of the day, everything whatever you see, you feel is kind of an illusion. Whatever the way you see, you have seen that in virtual reality as well, right? That
Yes, sir.
end of the day you started to feel that you are actually in that environment which is actually you are feeling. Maybe that is not real, okay. All right. In geometric transformation, we have actually find like at least 4 of the functions, but the first 3 functions that we are going to discuss, right? So, Antor, can you tell me about what is translation in general? What actually you can feel, Antor? Translation. We have done so many translation in English exam, right?
Yes, sir.
What was that? That we had in SSC or maybe in the school, we started to learn English, or maybe it is actually the best exam to show someone that you know English, right?
Translation.
Okay, I'll go to Ria, Khadija Rahman, Ria.
Yes, sir. Yes, sir.
Yes, Ria, what about translation?
In general, sir.
Hmm?
In general, translation means converting something into new. In English, we can say translating something into complex, compound, simple.
Yes, one thing is very important in translation. I'm telling about, say, like in the English language as well. You see that the conversion we do, but no change. No change in what? In the
No
meaning,
change
Sir.
in the
right?
meaning, sir. Yes, sir.
Translation, the first thing is actually you cannot change the meaning, right? It is actually changing the formation. Now, for this case, in our actually discussion in graphics context, the geometric, the transformation, the function for the transformation, the translation is actually changes in the position of the object, but no changes in the object. Do you understand? So that nothing will be changed, only the position of the object will be changed. Okay.
Yes, sir.
Okay. Ritu, can you tell me about what is scaling?
Yes, sir.
About the scaling, another function for the transformation.
So scaling means it's something arranging the series
Arranging the series. Okay.
and um,
Okay.
I
Scale. Do you know the scale, right?
yes sir
Scale, we call it scale for using the ruler, right?
yes sir
Another scale we call which actually measure the weight when you go.
measurement sir I want to
Okay.
say the measurements of something
Okay. For something, if you go for measuring,
yes
that
sir
actually related with the size or the weight,
yes sir
right? That's
yes
so that scaling is a function when the object actually having a different sizes. So the changes we do
yes sir
here related with the size, either it is getting a size means actually what an object can get actually expanded, right? Or maybe it can be reduction for reduced in its size, or maybe it can have changed a shape. These are the possible changes, right? So that function is actually scaling.
scaling yes
Okay,
sir.
that's good. So, and maybe Pappu, yes. Pappu, can you tell me about the rotation?
Rotation means rotate something.
What do you mean by rotate?
Rotate means one object we can rotate by a displacement, and again it will come its center. Its center called axis or axis. Depending on the axis, we can rotate an object.
So you are explaining in a complex format, so it's difficult to understand. Do you think that whatever you have said, your all other friend have understood?
No, sir. I understand only rotation means rotate an object.
Rotate an object, that's very good. But you see that simple thing to explain is very difficult, isn't it?
Yes, sir.
Now, what is actually rotate? For an object in a space, you have an object and it has been rotated. Now, how you do gonna actually explain that in a geometrical terminology? You see that for rotation, you must need actually some point on basis of that you will rotate, right?
Yes,
Because
sir.
if I say like, okay, rotate by 60 degree. Now, how do you gonna measure the 60 degree? I need a point at first, and from that actually I'll count that it will be rotated. Now, you can rotate in the both side, isn't it?
Yes, sir.
You see that you can rotate in the both side. Even you yourself, you can rotate from left to right or right to left, like this way in a circular mode that you can rotate. So that mode or the way of that rotation, do you have some way for identification? We don't say left to right or right to left. Is there any standard way that actually we can identify that which way we are rotating? Pratasha, is there any identification anyway?
Sir, by fixing a center, we can change the position by changing the degree.
Right, but the degree, you are actually, I'm telling 60 degree rotation. Now, which way you will go? You will go from left to right or right to left, that way, right? Now, this one also actually can be defined. There is a standard way of identification. So I'm just asking that if anyone know that how do you.
Clockwise or anti-clockwise?
Excellent, Ria. Yes, that's actually clockwise and anti-clockwise. Clock has been used here for actually mathematical that way of rotation that can be identified. Right, that's fine. So these three function actually that we are going to discuss, and translation. Already you see translation in English to Bangla, Bangla to English. What actually happened? The meaning does not change. Okay, and that means actually the changes of the form, the object that will be on the space from one position to another position, but it will not change in its size, in its rotation. It will not be changed in the translation, simple translation, when actually it will be. While in scaling, that actually there are object will be changed in the size especially. Okay, and you see that whenever in the dimension, different dimension, an object in a 3D object can have a at least 3 dimension, right? Now in the dimension, if you have a small or big, there are chances that object can change its shape as well. So this is very powerful actually, the transformation function, the scaling. While in the rotation, you can go for clockwise or maybe counterclockwise. That actually can be some degree of orientation. That is, in another term, it's called the change in the orientation when you some degree apply in there. Okay, that's fine. And mirror reflection is actually the coordinate to coordinate that actually object you can see. We'll see that what actually it is as well. Okay, so that's actually our main function. Let us go for attendance. I can just let me tell you that we will have 2 times attendance. Okay, so that the second time also I'll take the attendance, and don't worry, that also can be managed. Okay, because I found like when the attendance is done, then a good number of students actually left. Okay, maybe they are busy with some other activity as well, but then I cannot actually accommodate the attendance then. Okay, please come to the video for a while, please. Okay,
Yes, sir.
Allah Jannat.
Yes, sir.
Okay, Jannat. Ashikur Rahman Ashik. Okay, Ashik. Muhammad Alamin. Muhammad Amin. Nishat Ara. Shoidul Islam Antur.
Present, sir.
Okay, Antur. Sumaya Akhtar. Sumaya Akhtar. Arifa Akhtar Ritu.
Present, sir.
You are in outside?
Yes, sir. Actually, sir, I'm going to for internship, sir.
Oh, okay, that's fine.
In
Oh,
internet. That reason, sir. I need to go one office.
all right. Okay,
Okay, sir.
yeah, you just
Sir,
get connected and wish you
yes, sir.
good luck.
Thank you, sir.
Yeah, you just continue as much as possible.
Yeah, okay, sir.
Okay, Jinatun Nessa.
Yes, sir.
All right, Jinat. Parvez Alam.
Present, sir.
Okay, Parvez. Ridwan Ahmed
Yes,
Ratul.
sir.
Okay, Ratul. Salvi Saba.
Yes, sir.
Okay, Salvi. Zakaria Hassan
Yes,
Papu.
sir.
Okay, Papu. Maria Mehjabin.
Present, sir.
Okay, Maria. Israt Jarin.
Present. Present, please, sir.
Okay, Jarin. Abdul Khalek. Mohammad Abdul Khalek. Rabina Afrin Ami.
Yes, sir.
Okay, Ami. Tajnova Yasin Esha.
Yes, sir.
Okay, Esha. Sharia Tayon.
Present, sir.
Okay, Tayon. Hussein Ahmed Antur.
Present, sir.
Okay, Antur. Protasha Roy.
Yes, sir.
Okay, Protasha. Sharnika.
Yes, sir.
Okay, Sharnika. Khadija Rahman Ria.
Present, sir.
Okay, Ria. Rahat Islam Rupu.
Present, please, sir.
Okay, Rupu. Mahmud Akhtar.
Yes, sir.
Okay, Mahmuda. Didar Al Mahmud. Didar Al Mahmud. Do you have any contact with Didar? Anyone?
Yes, sir.
And any? Do you know any updates, Ria?
No,
He's
sir,
not.
I haven't messaged him for a week. I will, no, sir. I'll know for.
Yeah, just if you have any communication, then just inquire that he's not coming for last few classes.
Okay, sir.
Usually he doesn't get that much absent.
Okay, sir.
Tamanna Tabassum.
Yes, sir.
Okay, Tamanna. Saif Mahmoud Sifat is there. He is having. He just messaged me. Fairuz Tanjimachal.
Sir.
Okay, Achal. Shetuli.
Yes, sir.
Okay, Shetuli. Mustafa Idam Uday. Uday is absent. Okay. Sadia Hussain Mori. Sadia Hussain Mori. Sadia Akhtar.
Yes, sir.
Okay, Sadia. Mantakimur Rahman.
Yes, sir.
Okay, Mantakimur. Atik Faisal Iman.
Yes, sir.
Okay, Iman. Rahul Debnath.
Yes, sir.
Okay, Rahul. Nishat Tasnim Jyoti.
Yes, sir.
Okay, Jyoti. Sadat Mahmud Khan.
Yes, sir.
Okay, Sadat. Firdaus Hassan Rifat. Firdaus Hassan Rifat. Minhaj bin Monib.
Yes, sir.
Okay, Nahida Islam.
Yes, sir.
Okay, Nahida. Hasibul Hassan Shanto.
Yes, sir.
Okay, Shanto. Sharmin Sultana.
Yes, sir.
Okay, Sharmin. Ryan Hussein.
Yes, sir.
Okay, Ryan. Alamin. Muhammad Alamin. Tariqul Islam.
Yes, sir.
Okay, Tariq and Ashikul Jaman.
Yes, sir.
All right. Anyone missed? Anyone? Okay, that's fine. All right. I'm not putting that finally because I will come back again maybe later. Okay. Let's continue then about the discussion. We are doing this transformation function. Understanding this function is very important, as you know that if someday if you want to work actually any animation or a graphics development actually organization that as a software specialist, then you definitely need to know these are basic. Okay, and if you use some software, maybe you don't need to know those, but actually you will develop something for any complex work, then you must need to know those actually. So for translation, we said no changes in the object, but the changes in the object's position. We said a object is actually what? The object is actually a set of many number of points. Okay, those are in the space. Think about this house, as you can see in the image here, that the house is actually consists of say hundreds of points, created with many different lines, and that has been, now it is actually in a position of that space. Okay, that is space having a boundary indicating that maybe x and y coordinate, we can understand that this object having some specific, every points have a value of those. Now I want to move that object from this position to this position, and you see the object has not been changed, nothing has been changed, the size or maybe the shape or anything has not been changed, but its position has been changed. So every point of that relevant of this, say like 100 points in here that created those 1 2 3 lines, 4 lines, 5 lines, 6 lines, and the other this 4 3 9, so 6 9 15 lines actually created this shape or object. Now those 15 lines are actually you also find in here, only every point has been changed its actually value for the coordinate. Now if you check that changes in that coordinate, that actually from this object to this object, this has been actually the same for all the points. Okay, so that's actually called the translation factor, means with some factor it changes has been done. Now this can be put down in a formula as well, that how it can be calculated. So in translation, an object is displaced. Okay, displaced, so that move to one place to another place in a given distance and direction from its original position. So direction is also important, as you can see, because from one point to another point you are actually going in the space. Now the direction also has to be given. It shifts all the points of an object by an equal amount. That is actually we are talking about the factor. Okay, so whenever a point P is defined as P is having say like x and y coordinate for any random point on that object, say like that is P. Now the translate it to point P prime, okay, which is maybe x prime y prime, and the distance in x parallel to x axis, and dy is actually parallel to y axis. That means the distance factor, say like this is my P, just for consideration, then the p prime is in here now. So how far actually it has been moved for the x coordinate, that is actually the dx. Now every point in everywhere, if I have a point in here, say like one of the point, that is also for x coordinate, that dx unit or factor has been moved. Okay, so at the same way the y factor, say like this point, and now the new point is in here. Now the changes in here on the y coordinate is dy or ty or tx or dx, whatever you can say it. Now this is actually the translated factor. So you can see here the changes of the factor is also relevant with the x and y coordinates. So two values it can have. So if it is, then the new, that x prime is actually the old value of x plus the dx, and also the new value of y is actually the old value of y plus dy. So that if I can actually define that in the column vectors, so you can find like P, a point, is x and y is two-dimensional that we are discussing. So P prime is actually the new point x prime and y prime, and T is actually the translation factor, is d of x and d of y. So we can say the new point we get P prime is equal to P plus T, right? Is it okay to understand?
Yes, sir.
Yes, sir.
Okay, let us check with this one, that translation moving, actually we said all points in an object along the same straight line path to a new, in easily to understand. So like the path is represented in a new position. So like this point, that blue color point, is actually representing an object. We know that an object, when we do understand, actually it's a, say like the house just now we have seen, but it is consist of that hundreds of points, right? Just for understanding the function, we consider a single point. Okay, a single point is representing an object. So it is actually translating, means actually it is moving from one point to another point. Okay, so to a new straight line. So you can see here that it is actually moving from here to that, now become the red color. That point is actually the new position. So the path is presented by a vector called the translation or shift vector. That translation factor, as already we have seen, tx or dx that we have called, or ty or dy. So we can write the component like the new points x coordinate is actually that old points x coordinate plus the translation factor for the x coordinate. Okay, and the y coordinate for the new position for that point is actually the old points actually coordinate plus the new position. So that is actually the tx, that movement. For the ty is actually y coordinate, the changes
Sir,
it has
is it
done.
mandatory that every time the x and y both coordinate will be changes?
If you move, definitely your x and y will be changed, right?
Like if we go through horizontal or vertically only
Mhm.
after this point, that time only one value will be changes, isn't it?
One value will be changed, but the other value is not changing in regarding the previous one. But still, that is a value. Your t of y will be 0.
Yes, sir.
Do you understand?
Yes, sir.
That is actually numeric value that you are talking about. But the changes, the object's position is changing, isn't it?
Yes, sir.
According to your visual experience, if say like I can understand what you said. Say like this point is now in here.
Yes, sir.
So the t of y is actually 0, but t of x is
X
there.
is
But
there. Yes, sir.
according to the space, it is actually changing. So we always have to consider that the space changing means actually x and y coordinate is changing, right?
Yes, sir.
Okay, because one thing is important. You know that this is, you are considering also as a point. But I just said like this point has been taken as an example. But if we consider this one, that the example just we have seen for that house. Now that house, if it moved in here, right,
Yes, sir.
then maybe randomly all the points according to their position, that may be not changing their y coordinate actually, as like ty would be 0, right, for all the points. Means releve it to each to other, not actually one point comparing to another point of the same object. Say like this is my p1, this is my p2, this is my p3, right? Now p3 is moving from here to here, p1 is moving from here to here. Now for p1 and p1 prime, p3 and p3 prime, you can see that their y coordinates are not changing regarding to their position. Okay,
Yes, sir.
but whenever so that you can see that not individual point we can actually move when we apply the transformation function, especially near object or content in the environment that you have in the image. We need to apply in a all the points in a matrix format. So we enter everything in a all these points in one place, and then actually we apply that actually that function so that it is moved. The object entirely has been moved. Now for understanding easily, um, that's we are only considering one of the point to understand. Okay, all right.
Yes, sir.
Now in the matrix, so that we can say like x prime and y prime is equal to x plus x and y plus tx and ty, right? So the point we can get actually x plus tx and y plus ty. So that's actually we can get. Now look at it here with the value. If we have, so like we have a point p is 2 and 2, tx is actually 6, that means 6 unit x coordinate translation factor has been done and y coordinate has been done 4. So what should be actually my p prime or x prime or y prime?
Say 8, 6.
8 and 6, right? Exactly. So this is my x, this is my y. So x plus dx is actually 2 plus 6 is 8. So x prime, the new point's coordinate will be, x coordinate will be 8, and 2 plus 4 for y plus d of y will be actually new points y coordinate value, so that will be 6. So 8 and 6, that will be right. So if you just count as well, you will find like this is actually 8 and 4 for that. So if it is 2 2, as you can see that then that is actually 2 2. So 3 4 5 6 7 8, and 1 2 3 4 5 6. So this is actually the pixel for that object. So 8 and 6, that's fine. And now if we go for rotation, okay, we already said that rotation is actually changes in the object's actually orientation. Okay, orientation is actually on basis of some point we are either going in the clockwise or counterclockwise. Okay, so that's actually the rotation we know, and you need some degree for the rotation, right? So about the origin is considering when you have a xy coordinate, and the center point, that crossing over point, the origin point is actually we are considering, that is also we called actually on that basis of that point, that degree of that orientation is done, and the direction of that rotation is counterclockwise. Okay, it just a little bit you need to remember that if you go counterclockwise, the reverse way of the clock, because clock is rotating like this way, so if you go clockwise, then your rotation is negative. If you go counterclockwise, then your rotation is positive. Okay, so remember that one. It would be important later actually. So your rotation, when actually you are doing counterclockwise, then actually it is positive. Now this orientation has been changed on the basis of the theta degree, as you know that about the origin that has been. Now look at this image here. So this object is actually rotated some degree that we are calling theta, as which kind of rotation has been done, the positive one or negative one? From the image that you can feel, the positive one, right, as it is happening the counterclockwise. Okay, as it is going in this way, that arrow is showing that which way it has been done. And the same way for the transformation function for that rotation should be the of any point, we consider any point P is actually now new position becomes like the P was in here for that object. Now the new position is actually P prime here, right? So it is actually changed the position. Now how actually I can find out that change of that point? Now you can see here, for that object to rotate, what I need to do, all these points for this object, say like we have P1, P2, P3, P4, P5, this 5 of these points, if I actually apply the rotation function, they will be in different location, this P1, P2, P3, P4, P5. And then actually if we join them, we can find the object has been rotated according to the degree. Okay, so this is the way the object can be rotated. And this transformation function is actually P prime is equal to the R theta, the rotation function, and then actually the P. Okay, and this P prime is actually nothing but the X prime and Y prime. Okay, as you can see that this is actually the X prime and Y prime, the P prime, and the rotation function is actually the cos theta minus sine theta cos theta. It's a two-dimensional that matrix that we are actually going to explain with that. And then the old point, that x and y. Now if we actually that multiply this rotation in the dot product as it is, we can find like x prime is actually x cos theta minus y sine theta, and y prime is actually x sine theta plus y cos theta. Okay, if we just do that one, so this is actually my rotation function, and this is actually my x. So rotation must be done about a point. We must need a point, otherwise we cannot do it, and is denoted by theta degree that rotation is done, and it should be that theta degree angle. So this is actually the function. The new point is equal to rotation function with the old point. Old point is x and y, new point is x prime and y prime, and finally we get actually that x prime is actually x cos theta minus y sin theta, and y prime is x sin theta plus y cos theta. Now how do you gonna actually find that one, that theta degree, if you know that how much degree that you are having rotation? I'm saying 60-degree rotation, and the point we have say 5 and 7, so that we can easily find out that 5 cos 60 minus 7 sin 60, and can give you the new chord points, that p prime, that new points actually x coordinate value, and that 5 sine 60 plus 7 cos 60 will give you actually the y prime's value. So if we also have we'll check that how this actually can be generated, this equation, okay, with one of the example that we will see. Whenever the rotation happens in the space, as you can see that this is actually the about the origin, that theta degree you do count, and it is actually shifting that all the points according to that degree of the rotation. Okay, so that you can see here the 30-degree rotation, the positive rotation, it has been done in here, and counterclockwise about the origin, clockwise is about the origin. So that we have, if we go for also for this one to understand in detail, as you can see, rotation is reposition of all points in an object along a circular path in the plane center at the pivot point. Now we will find, like whenever we have about the origin and we have a rotation, it may create a circular path for all the points. Okay, this is easy to understand when we have a single object, a single point. But if we have a shape of that point, all of them relevantly also make a circle actually when they are having a movement according to some degree. Okay, so that's actually to a circular path and centered at the pivot point, which is that origin point, as we are actually considering at this moment. So at first we'll assume that the pivot point or pivot point is at the origin. Okay, on the basis of that, actually the theta degree rotation you do, like a positive rotation, it's happened, and it's actually create a circular path in the new position when it comes. Okay, now this theta degree that actually we have said, that cos theta minus sin theta and sin theta cos theta. Now how actually we can generate that with that new position to old position? We will see some trigonometrical actually involvement here. As you can see that my point P is actually having x and y coordinate, the old point, the old position for the point, and it is having a theta degree, sorry, that is actually phi, isn't it? That phi actually is actually with the x coordinate alignment, actually that much degree it has. Now what actually the x and y indicate? The distance of the x coordinate and distance of the y coordinate, right? And we said it is a circular movement it will have, right? We just have seen in here, if it is circular degree, then you see that this line and this line is equal, right? Yes.
The length of line, sir?
Yes.
Yes, sir.
It will be equal, because end of the day, if we have a say like an object, let me draw them also. Yes, Ashik. All right. If we have say like an object, we have just said it's very difficult to draw actually, not so easy. So for if it is my origin, and these are the multiple points, Let me try to actually do that. Say like some degree. For this chapter, I was having a problem in my mouse. I bought a new mouse actually for this chapter especially. But I say it is not appropriate, but just consider that if this is my P1, P2, P3, P4, P5, okay, so that is P1, P2, P3, P4, P5 prime, okay, we just consider that is a new position of that. This is actually say like all the points are having the old one. This is the P prime. Actually, it is not right because um, we have to consider individual all the points. Okay, so say like this point we just consider maybe this point only. So like this is P1, P2, P3, P4. So like this is P4 and this is P4 prime. For this point we are talking. Now what happened? It's saying that look, if this is actually relevant with this point, this is also relevant with this point, this is also relevant with this point, then this also will be relevant with this point, like this way. This is maybe this point, this is maybe this point. So if we have a rotation, then all the points like this one, actually whatever the circle it will create, this one also will create, this one also will create. All these points create actually individual circles, okay, and so that the distance of this point and from this origin to this point and from this origin to this point should be same. Like this point, distance of this one and this one should be same. Okay, that's why it's said like it is created a circular path. Okay, so if we consider that point to point that created circular, then actually we can consider that is actually the radius, right? The distance from the center to the circumference. So from the same concept has been actually applied in here to understand, so that whenever we consider that one, that movement of this point to this point, then actually we consider that is actually radius. So in here, so that line is actually I'm considering that is actually the radius. Okay, now I have a theta degree positive rotation, okay, from the origin. So my new position P is now P prime, that means X prime Y prime. Okay, and you can see that the theta degree has been rotation has been done, and this X prime Y prime, the P is now moved on in here. Now I'm considering this line is actually their same size, that R, and just considering as it is a R, right?
Yes,
Can we do that? Do you understand this position now? That is important.
yes, sir. Got it.
Yes,
Now,
sir.
for this point, the X prime is actually the distance of that X coordinate, and Y prime is actually that coordinate. We can actually draw that a triangle, if we can consider they are actually now form two triangle, right?
Yes, sir. We can draw
Okay,
this.
all right, yes, that's good. Now we consider that was actually theta degree rotation we had. Now this actually angle is actually we give it is maybe phi, the degree is actually phi. Okay, now for this triangle if we go, we know that what is actually the cos phi. Cos phi is actually that the base, right, and that abscissa, as we know that bhumi by otibhuj, right, for cos theta.
Lombo by bhumi, sir.
Cos theta is actually bhumi by otibhuj,
Yes, sir.
right? That is actually x, that coordinate for this triangle. I'm actually talking about this triangle. So cos phi is actually the base, which is x, and that the abscissa of the distance, which we call it radius now for that. So we have done like cos phi is equal to x divided by r, and sine phi is actually that perpendicular line, which is we call that lombo by both inputs, right? So that y and by r, that sine phi, right? That we know the formula for the trigonometrical formula, we know it. So cos phi and sine phi that we get. Now we simplify that one. So x is actually r cos phi, okay? We just take that r in that side, and y is actually r sine phi, okay? We got those two equations, we need it later. Now we go for this actually triangle. So if we go for this triangle, what should be my degree? Cos theta plus phi, right?
Yes,
If
sir.
we go for this triangle, that means this angle and this angle or both should come, right? So we should go for cos theta plus phi, right?
Yes,
So
sir.
that we got actually cos theta plus phi, right? We take the phi at first, then we take the theta. Now what is actually cos theta plus phi in here? Again the cos theta, so that means actually that the base, that means x prime divided by r, right? So x prime divided by r. So if we go for actually simplification, so x prime is equal to r cos theta plus phi, right? Now this is actually what? Cos a plus b, that formula, if you can remember. Cos a plus b is actually cos a cos b minus sin a sin b, right?
Yes,
If
sir.
I am not wrong, you can recall that in the formula. So cos a plus b is actually cos a cos b minus sin a sin b. So that if we just yes, Ritu, you can leave, no problem. So that if we just have that multiply that one with r, so ask r cos phi and cos theta minus r sine phi and sine theta. Now we know that what is r cos phi. We know that r cos phi is actually x, and r sine phi is actually y. So that r cos phi, we just replace that one with x cos theta, and r sine phi is actually y sine theta, right? You see that we already got that equation, which we were finding actually for that equation for the, where it is gone, that the equation for that new points actually coordinate is actually that the old point, that is x cos theta minus y sine theta. So and y is actually x sine theta plus y cos theta. So we got actually the x coordinate is x cos theta minus y sine theta, okay, the equation for that one. Now the same way, if we consider for sine theta phi plus theta, okay, as we know that that is actually that perpendicular line, which is the y prime divided by r, okay. So y prime is actually r sine phi plus theta, okay, and sine a sine b, we know that this is actually r cos a, that means sine a plus b is actually cos a sine b plus sine a cos b, okay. That is actually the formula, that sine a cos b and sine cos a sine b plus sine a cos b, okay. So sine a, that means phi, that you can also get it from here, that sine a plus cos b, that means cos theta, and cos theta cos phi plus sine theta. And again that r cos theta, r cos phi and r sine phi is actually, r cos phi is x, r sine phi is actually y. So we just put it, r cos phi is x and r sine phi is actually y. So we got y prime is actually x sine theta plus y sine y cos theta. So that in the equation we got actually x sine theta plus y cos theta, and that's actually the positive rotation, and the rotation matrix is actually this one, cos theta minus sin theta cos theta. If we multiply of these 2 points as well, then also we actually get it, right? Do you understand? This is actually how that formula has been generated. That is actually the concern. Yes.
Sir, if we see an example, it will be much more clear.
Yeah, we are coming in the example. I'm just let me clear up the discussion here for the basic functions. For the scaling now, just rotation we have understood. The scaling, as you know, that that is also has to be done according to the origin. So you need the origin actually. Without that, it is not possible. So the object we had now, say like the object I had this one. Now you can see the new position of that object as it is, the size has been reduced here. Okay, so it can be vice versa. The size can also can be expanded. Okay, it can happen. So the process of expanding or compressing the dimension of an object is actually scaling. That's why I said like this is actually very powerful actually transformation function, because you see that the other two, translation and rotation, whatever we do, the object, that shape does not change. Okay, but in there is a chance of that scaling can change the shape as well, the position, the size, also the shape also it can be changed. Now positive scaling constants, so that s of x and s of y, that is actually the constant or factor, that scaling factor, are used to describe the changes in length with the respect of x direction and y direction respectively. And a scaling constant greater than 1 indicates an expansion of length. So if the that expansion, that scaling factor, actually the values are more than 1, then it has an expansion. If it is less than 1, then actually it is a compression or reduction. Okay, the scaling translation can be defined as s of x, s of y is the new point p is the scaling factor with the old point. So that x prime, that the new position for the x coordinate become s of x, the scaling factor with the x, and y is actually s of y with the y. It should be s of y, not the x. Okay, so that this is very easy. You can find the values like when we are thinking about this scaling factor from the origin, that p is defined as p, say like this one is actually p, which is x and y, and a scaling factor whenever we have applied that s of x along the x-axis and s of y along the y-axis, then the new points position that we get, the x prime is actually s of x multiplied with that old points value x, and s of y the multiplied with that y points value. So that defining the matrix is actually s of x 0 0 s of y, the positional vectors there, as you can see there, for the x coordinate, for the y coordinate. So that whenever we multiply that one, you get it like x s of x plus 0 into y, that means that is 0, and the y coordinate value we get s x into 0 plus s of y dot y, so y into s of y. So whatever the point we have, if we just define that what actually my scaling factors are, if we to multiply, then actually we'll get the new positions or points value there. Okay, already said, if your scaling factors has been given here, that s of x and s of y, if their values are more than 1, okay, then the magnification happens, means the size expand. If the value goes less than 1, then actually it gets reduction or the size gets small. If the value is 1, then what happens? Yes, if the value is 1, then actually what happens? Yes, yes, Mantakimo? If s of x and s of y, the value is 1, then actually what happened?
Same size.
Same size, right? No changes, right? Yes, that's good. So that it does not have any changes. So do you have minutes left? No, it is already over. Uh, Actually, we need at least 2 hours classes for this type of chapters. We have to stop in here. One thing is important. I told you that this weekend, okay, Friday or Saturday, any day in the evening, we are going to have a session. So do not miss it. I cannot give you very long before notice. Maybe if I want to take maybe tomorrow afternoon, maybe in the morning, I'll give you the link and also the notice in the Google Classroom. Okay. But definitely you will have a notice. Then only you can have an extra session.
All right,
Do
sir.
not consider that it is final. Maybe it can be on Saturday as well, right? Do you prefer a daytime or evening time?
Evening time, sir. Sir, evening time, sir.
Sir,
Evening time.
evening time.
Okay. I don't know what would be the reason, because those 2 days also you don't have anything on the daytime, right? Any reason, anything, or any engagement do you have? Why I am asking, because sometimes many of us have some evening invitation, right, or something. So that's why I'm just asking you beforehand that do you have any problem or not?
No, sir. Basically, this day we get awake in evening.
Okay. All right, that's fine. Then we are definitely going to have in the evening, maybe. Okay.
All
All
right,
right.
sir.
Take care. I'll see you very soon.
Okay, sir. Assalamu alaikum.
Uday, you
Yes, sir.
arrived late, maybe, right?